The broadcast is now starting. All attendees are in listen-only mode.
Well, hi there, and welcome from Studio 27 in Sacramento, California, and to our audience and panelists across the U.S., Latin America, Canada, and the rest of the world to today's webinar, Maps, BI, and Network Management, Together at Last, sponsored by Oracle and hosted by Directions Media, the voice of all things location. Oracle and its partner ThinkHuddle are going to discuss how Oracle has addressed the challenges for incorporating spatial data and the dashboard capabilities of Oracle Business Intelligence into a new application called Oracle Utilities Advanced Spatial Outage Analytics. And more importantly, how this complements operational network management systems by enabling better business decisions during outages. Hi, I'm Mike Agron, the executive webinar producer with Directions Media, and I'm going to be your moderator and one of your hosts for today's session. And really excited to have you join us because we've got some great information and exciting updates to share with you. But first, I'd like to draw your attention to the right-hand side of the screen to some upcoming Directions Media events. And to get more information, you can do this by going to directionsmag.com/webinars and sign up and receive the Directions Magazine newsletter. In fact, here's how you can get some more information from Directions Media. You know, we've got a global audience of over 300 people from 28 countries, and we've invited you, along with other executives, managers, and operational level professionals from the utilities market, as well as anyone who has an interest in learning how to make better business decisions where location across the enterprise is important. So regardless of your industry affiliation or role, we're absolutely confident you're going to find today's webinar to be of value. Now, in just a moment, I'm going to be introducing Nora Parker from Directions Media and our speakers. But first, a little bit about housekeeping, because we absolutely want to encourage you to ask questions as often and as many times as you'd like throughout the webinar. We'll take them at the end in our Ask the Experts panel session. And to do that, if you'll see where my mouse is on the screen, you should have a control panel like this on your desktop. If it isn't completely open, just click on the double arrow here. It'll open up. And down here where it says enter a question for staff, go ahead and type in there. Just type your questions in there. We'll put them in the queue, and those questions that we can't answer on air, we absolutely promise to have a subject matter expert get back to you. We're also going to have some fun with some online polls, and we'll ask you for your opinion on a couple different topics. No worries, I'll walk you through it. You'll vote with them using your mouse. Also, a question we always get is, will there be a copy of today's webinar available as a recording? And the answer is, of course. You'll all be receiving an email, not only with a link to the recording, but how you can get additional information, and that should be coming sometime next week. And finally, we'd absolutely love to get your feedback on how today's webinar met your expectations. So at the end of the webinar, in your browser will pop up a survey. It's real simple. We're just going to ask you on a scale of 1 to 5, how did it meet your expectations, and a couple other simple questions. So again, we'd love for your feedback on that. Now let's get to the first of our polls. And I'm going to launch this poll on your screen. And what we'd like you to do is to answer, how does your organization use business intelligence? Is it A, we use BI data but not integrated with GIS? B, we use BI integrated with location but no map visualization? Or C, our business intelligence and GIS are integrated? D, we have GIS but no business intelligence? Or E, none of the above? I'm going to keep the poll open for just a little bit longer and let everybody vote, and then we'll share the results. And as I said, we're going to be bringing on Nora Parker in just a moment. And I see quite a few of the votes coming in. So I'm going to go ahead, keep it open for just a little bit longer. And looks like just about everybody who is going to vote has voted. So thank you for that. And I will now close the poll. And let's share the results. Pretty interesting. 31% we use BI data but not integrated with GIS. 6% we use BI integrated with location but no map visualization. 19% our BI and GIS are integrated. 34% we have GIS but no BI, and of course 10% none of the above. Well, thank you so much for that. And now, one of my favorite parts of our webinars is to bring on the senior staff from Directions Media. And let me do that by introducing Nora Parker. Most of you are probably familiar with her if you've been in the geospatial industry. but she is the senior managing editor of Directions magazine, and she actually helped found the publication in 1998, and she's also a member of the board of directors. If you remember her, it's probably as the founding editor of Business Geographic's magazine and as the chairperson of the conference by the same name during the 1990s. Now, one of Nora's other hats is being my partner and collaborator in producing our Directions Media webinar. So I'm extra pleased to have her come out from the control room and step in front of the microphone and share her insights. So Nora, I'm now going to turn this portion over to you, and welcome to the webinar from Colorado.
Well, thanks, Mike. And on behalf of my colleagues, I'd like to extend my thanks to all of you for taking the time to attend today's webinar. I'd also like to thank our sponsor, Oracle, for their support, and to Steve at ThinkHuddle for taking time from his day job to be here today. So let me talk a little bit about what the key points are of this webinar from Directions' perspective. First, historically, utilities have found it challenging to implement operational systems to monitor and control their networks in real time. Geospatial systems tend to have two roles. There's the actual working aspect of spatial number crunching and analysis, and then there's reporting and sharing information. Both of these play a role. In this case, integrating digital map displays and spatial analysis with these systems is very important. And equally important is sharing the operational data with the business decision makers. Both of these are hard to do, but we'll see some interesting approaches to these challenges during this webinar. And then, of course, you need to consider that these issues are not exclusive to electric utilities. The same sort of real-time monitoring and control systems are used by water and gas utilities as well as in telecommunications and many other industries as well. So the world is more dependent than ever on continuous availability of energy, and customers and regulators continue to demand more reliable service and faster service restoration when outages occur. So with that in mind, let's take a look at today's agenda. So you've heard from me. Next we're going to have Jim Steiner from Oracle, who's going to give us some background on Oracle BI and spatial in the enterprise. We'll have subject matter expert Brad Williams, also from Oracle, who's focused entirely on the utilities market. And then Steve Pierce from ThinkHuddle, who has a lot of experience with implementing these tools in the field. So I think you'll find this very interesting webinar. And again, I'd like to thank you for coming on, and thanks so much. And Mike, I'll hand it back to you.
Thanks, Nora, and talk to you soon. So folks, now we're going to bring up our good friend, Jim Steiner, who's Vice President of Product Management at Oracle Spatial, and his topic is Oracle BI and Spatial in the Enterprise. And most of you who are familiar with Oracle and Spatial probably know Jim. He also is in charge of the Oracle Spatial Products Group, and he's out of Nashua, New Hampshire. And he's actually been a key person behind Oracle Spatial Vision. And I've actually had the pleasure of working with him when I was at Oracle in the late 90s. So I'm absolutely delighted to have him join us today. So Jim is going to provide us with an update on Oracle BI and Spatial in the Enterprise. And Jim, absolutely, as I said before, delighted to have you, and welcome to the webinar.
Thanks, Mike. It's always a pleasure. As Mike said, I've been responsible for Oracle's spatial technologies for about 15 years now. And one of the things, we've probably done about 10 or so of these Directions webinars, and every time I do one, I find it necessary to take a minute to give a quick update on what's new at Oracle. I'm sure everybody knows Oracle, the database company. Over the years, we've made significant acquisitions in the area of middleware, and now I think we are much more considered an IT platform as opposed to simply a database company with our middleware and WebLogic suite and our service-oriented architecture technologies. In addition, I think many people are also familiar with Oracle as an applications company. We do have the leading applications in numerous areas, and many of you may think that we're primarily horizontal business applications, things like CRM and financials, human resources, and more recently business intelligence. But another thing that may not have caught your attention is that over the past few years, we've also added a broad portfolio of leading industry-specific solutions in areas like retail and telecommunications, transportation, pharma, public sector, project management, and utilities. Today, we're going to go into some depth about one of our new applications for the utilities industry. But before we do that, I'd just like to talk a bit about some of the major developments at Oracle and about the Oracle BI spatial features. While Oracle's changed in many ways over the past years, perhaps the most significant change happened almost exactly a year ago today with the acquisition of Sun Microsystems. In addition to fantastic software technology like Java and Solaris, we now have the storage and server technologies that have enabled Oracle to produce the Exadata database machine and the Exalogic Elastic Cloud machine. Oracle Exalogic Elastic Cloud is the world's first and only integrated cloud machine, hardware and software engineered together to provide a cloud in a box. The capabilities of these systems have had a significant impact on us. What it's done has been to change the infrastructure available to our customers for the development and deployment of applications. Exadata database machines are very powerful systems designed specifically for database workloads. A single Exadata database machine can have up to 96 CPU cores, over 3/4 of a terabyte of memory for database processing, with up to 168 cores for storage processing. It can have up to 5.3 terabytes of Exadata Smart Flash Cache and usable uncompressed storage of up to 150 terabytes per rack. It can also deliver up to 75 gigabytes per second of raw I/O bandwidth and up to 1.5 million I/Os per second. At the application server tier, an Exalogic Elastic Cloud machine can have up to 30 compute nodes and up to 40 terabytes of raw storage. Perhaps most important to the software infrastructure within Exalogic is the use of InfiniBand as the internal networking fabric. InfiniBand is an industry standard switched fabric communications link widely used in high-performance computing and enterprise data centers. For Exalogic, the InfiniBand fabric we use enables up to 40 gigabits per second bandwidth with a latency as low as 1.2 microseconds. So really the point here is that these are massively scalable, powerful, and performant systems. I mention this because these developments have had a major impact on Oracle's spatial technologies. It gives us the ability to address a much wider range of issues that our customers face through the use of geospatial technologies. And it puts a broad set of best-in-breed software and hardware technology at our disposal as we work to tackle these problems. Today we're going to focus on how applications use a technology infrastructure with native spatial capabilities to bring greater value to their customers. One thing we've done is to get beyond the basic integration of maps into business intelligence, where you can simply show pins on a map or draw thematic maps. For a number of years, we've offered the ability to integrate BI with Fusion Middleware Map Viewer to enable location intelligence applications. With the release of Oracle Business Intelligence Enterprise Edition 11G, we now have fully incorporated maps and spatial analysis into the BI experience, making map views, which is what the feature is called, a first-class element of the BI product. This is an out-of-the-box experience. No custom coding, no development required to integrate a GIS or mapping service with a separate BI system. So what does this mean? It means maps are built in. The key is that this is a configurable, metadata-driven system, not a message-based communications between systems. Configuration, styling, linking of dashboard elements, prompts, agents, user interactions, all these kinds of things are either built in or done using the standard BI setup facilities used for all other elements of the BI system. It's designed for the business intelligence, the business systems user, not the GIS specialist. And through our relationship with Navtech, map data is available specifically for BI with metadata and hierarchies appropriate for BI. And in addition, external data from real-time services and online mapping services can be easily integrated. This enables fully integrated visualization, supports drilling and multiple measures on a map, gives the ability to depict and detect spatial relationships and patterns across data being analyzed, and offers full master detail linking. This is a unique approach to the development and delivery of geospatial capabilities. The way we incorporate mapping and spatial analysis into many of the business applications that Oracle offers is done in a manner that allows the business user to experience the value of map visualization and location analysis in the context of their application. A recent IDC report points out that this brings the use of spatial information to a new dimension, making location analysis an inherent capability in both the technology stack and the applications our customers use. From a technology perspective, these include the Oracle database, the WebLogic application server, our JDeveloper Java tools, our TopLink object modeling tools, our SOA suite, and our complex event processing, Oracle's event and stream processing technology. You're probably already aware that Oracle offers a wide range of spatial capabilities through Oracle Database, Oracle Spatial, and Oracle Fusion middleware. These include scrollable interactive maps, spatial web services, geocoding and routing engines, 3D, LiDAR, network management, and raster imagery support. And these are all available as part of the technology infrastructure used by our customers, partners, and our applications development teams. We've offered location-enabled applications for a number of years, and more are coming with each new release. So, as I've said, this is so the business user can experience the value of map visualization and spatial analysis in the context of their application. Among the Oracle applications that incorporate location analysis are our Oracle Communications Unified Inventory Management, our Oracle Transportation Management, our CRM, our case management technologies, and our Primavera project management, as well as a wide variety of utilities applications for mobile workforce management, network management, and work and asset management. With the introduction of Oracle BI with fully integrated mapping and location analysis, we now have a new platform upon which geospatial applications can be developed. Today we'll be hearing from Brad about the first of a new generation of spatially oriented business application, the Oracle Utilities Advanced Spatial Outage Analytics. So with that, I'm going to hand it over to Mike for the next portion of the webinar.
Thanks, Jim. Thank you, Jim. And I was just thinking, come a long way since Oracle 8i back in the 90s, haven't we?
That's for sure.
All right. All right. So let's now bring up our next presenter, Brad Williams. And for those of you that may have just joined us, welcome. And we just heard an update from Jim Steiner of Oracle on the introduction of Oracle Business Intelligence with fully integrated mapping and location analysis, which, of course, now provides enterprises with a new platform to develop geospatial applications. So as Jim said, we're now going to hear from Brad Williams, who's the Vice President of Oracle Utilities Global Business Unit, and he's going to talk about the first of a new generation of spatially oriented business applications called Oracle Utilities Advanced Spatial Outage Analytics. As I mentioned, he's the VP of Oracle Utilities Global Business Unit. He's also in charge from a product management standpoint for outage management, distribution management, mobile workforce management, and work and asset management utility applications. Brad's got more than 23 years utility technology experience doing very innovative things. And prior to Oracle, he was a research director in Gartner's Energy and Utility Industry Advisory Services, where he focused on these various spaces. Brad, delighted to have you as a first-time presenter on a Directions Medium webinar. I'm now going to turn this portion over to you.
Thanks, Mike. Glad to be with you today, and welcome again, everybody. So, yeah, my background has been in the utility space, engineering, asset management, and I am really excited about the technologies that Oracle can bring to the utilities to help improve the overall operations of utilities, customer responsiveness, the customer relationship, and workforce management. And that's really what we're going to be talking about over the next few minutes. We're going to drill down into these utility applications. So location-enabled analytics, and we're all familiar with that. These have become rather popular in the last few years of these type of location-enabled applications, and they really fit nicely with utilities, mainly because of the primary role of managing geospatially diverse assets, whether they be pipelines, wires, substation, generation plants, supply, processing plants. All of those things are very diverse, geographically diverse across a utility's service territory, as well as the workforce, trying to optimize and manage your workforce across your service territory, and then the customers. The customers certainly are location-based, and being able to manage them from a spatial aspect really opens the doors and to improve the level of service we can provide to utility customers. A lot of this has been driven by the need of managing certain trends in the industry, certainly major events, these major earthquakes, fires, floods, hurricanes. Those kind of things are big deals amongst utilities, and being able to get information to those that are supporting the responsiveness becomes very important. And of course, you don't want to impact the actual edge application, such as in the case we'll be talking about today, outage management. You don't want to keep adding lots of users to your outage management system if all they want to do is get some high-level information of what's going on. And thereby, we need to have another way of getting that and make it meaningful for those who need it. Certainly, customers are demanding more as they have become more technologically savvy. Web-based interaction, as well as PDAs and so forth. The expectation of getting information about their specific circumstance is becoming more and more important. Certainly, utilities have had to manage constrained budgets in times when assets are aging. Aging workforce is another issue where how do you collect knowledge about parts of your network, parts of your utility, and make it available for those that come behind. And and by the way, those that are coming behind are much more technology savvy than those who are going to be retiring over the next few years in general. So how do we deal with that? Another huge issue is data quality. Is as we are moving into a smart grid environment, the dependency on systems and data is growing exponentially, and the quality of that data becomes very important to the day-to-day operations and safety of the utility. So being able to look at and analyze data and data quality from a spatial perspective can be a real enabler to some of the smart grid issues. The other trend we've seen is deeper levels of analytics, pattern recognition, for example. We've got all of this data coming back at us in the utility perspective, particularly smart metering as an example, where we've never before had interval meter reading. We used to have a single kilowatt hour per month read and to produce a bill. Well, now when we have 15-minute intervals, how can we leverage that data to help drive performance from an asset perspective, a customer relationship perspective, those kind of things. So as you can see, the possibilities are endless on how we can leverage spatial data to help drive utility performance. I've already talked about the rise in business popularity, driven by simple mapping applications. I think we've all used Google Maps to find directions to a certain location. And those are moving into the business world, and we're seeing a rise of what I would call niche applications to help support some of these trends and expectations that business users, and particularly utility users, are demanding. If you look at this graphic here, it kind of shows where utilities are at with managing information. And you see this big blue dot to the upper left, and that would be these enterprise BI applications. The CIO will go and buy a large BI tool, but the problem is the business users have their own ways of looking at data. To the far right, we've got the what we call these information anarchists, or those that have spreadsheet or their own their own in-house or their homegrown applications. In the middle, we'd have these silos of niche applications for very specific purposes, and all have different sources of data, different types of users that would go and purchase these siloed applications. And where we want to move to is the value of security and information data quality that you would get with an enterprise type application, but the niche or end user capability, the end user functionality that really enables these applications to drive performance. And that's as we move across this red line on this axis. That's what we're looking for. So that's what we have introduced, is a very specific utility application to support the value of enterprise BI, but also the spatial enablement of that, and also pre-configured for specific utility applications. So Jim already mentioned that this is kind of the basis of that, is that we have these BI capabilities, but all of the Oracle technologies and ability to bring in multiple sources of data to leverage to make that BI data even more effective and more valuable for utilities to improve their operations. So not just maps, not just where your crews are, your customers are, but all of the capabilities such as bringing in your network model, being able to trace out your model to specific customers and assets, being able to bring in your AutoCAD drawings of substations and of assets that go with that, and certainly overlay LiDAR and other types of raster imagery into that to further improve the value of that in order to improve that. The next slide will be talking about the real-time data streams that we can bring into this, and we've got the thematic map overlay with weather data. So this would be the specific outage information that a utility user would see, is the thematic maps of outages, where my outages are, where my crews are, and overlaying key information like weather. And so we can show the Doppler radar imagery and the forecasts of what the impacts are of weather front that's coming in, show lightning strike data, and be able to drill down into how does that spatial relationship of a lightning strike on top of a transmission line or distribution line becomes very effective in trying to understand what's going on in the network. In this other example, we've got real-time feeds of the weather stations, where we can show video streams as well as the temperatures that go along with that. So you can see we can have other sources of video streams that we could bring into there, like if you've got videos in plants or substations, the ability to bring those in as part of the tool. So in this case, we're showing the actual outages, and you can drill down into these outages and show the tabular view that you would typically see in some type of a KPI, BI type report, but these can be interlinked, and so we can show down to specific assets of what has caused the outage, what crews are assigned, estimated time of restoration, downstream customers that are impacted by this outage. So you can see the value of a tool like this for like a call center, or if you have a storm center that you bring together to manage the specific storms that go with that. On the next slide, we'll look at the thematic themes that I introduced on the first graphic that we showed, and we can drill down to the specific transformers in this case, and the specific assets that are related to an outage, or looking at loading information. So this is kind of where we're going with that is not just outage information, but asset analytics. Is we can identify what the specific loading is on a specific transformer. Now that we have a relationship of meter data management to customers, to transformers, we can actually identify the specific loads or transformer load management and start to look at what is the loading impact. And this becomes very important when we start introducing customer technologies, particularly electric vehicles. There's a big concern that as more consumers are starting to buy electric vehicles, which ultimately could double the peak demand that a utility manages on a customer-by-customer basis, that the impact at the transformer and subdivision level could be pretty extensive, and the ability to manage that information and manage the expectation of that becomes very important as we link the customer to the assets. In the next graphic, we can show these thematic maps, thematic themes. So in this case, we're just showing a specific zip code, but it could be an operational service territory. It could be political boundaries of politicians or cities, counties, those kind of things. So you can get a quick snapshot of what's happening in my jurisdiction that's important to me. And these are just bound by spatial polygons that the utility puts together, and the spatial data relationship is what's driving the answers that go with that. It's not a direct database relationship, but the spatial correlation to that's driving that. And then this next example talks about the heat maps, which are a concentration of data density. So in this case, this is outage density. And so what you would suspect here is that these two blocks are high-rise apartment buildings that have a high concentration of customers. So if your goal is to improve customer minutes of interruption or a SAIDI reliability target, then directing crews to these locations first to try to restore this larger concentration of customers that are out will improve your overall outage statistics. And so using this kind of spatial enablement becomes very important. This is also a great tool for asset management, where you can look at asset loading or asset condition concentrations, where you've got poor performing assets or assets that their inspection history have shown that these are in the worst condition. So you can kind of highlight areas that you might want to accelerate maintenance programs or accelerate replacement programs based on known condition or based on asset performance, loading, outage history, those kind of things. So this is just to give you a taste of that, and we are moving these tools beyond just outage and distribution management, but into meter data management, customer information management, asset and workforce management as well, or other key areas that will provide out-of-the-box functionality, but certainly make the tools available for utilities to customize. And that's what Steve Pierce will be talking about in the next section. So back to you, Mike. Thanks.
Thanks, Brad. And stick around. We're going to have you back in just a little bit. We've got some questions that have come in, and I know they will be directed and listening to your responses. Well, now we're going to come to the final presenter and get a little bit under the hood. And Steve Pierce, who's a spatial systems consultant from Think Huddle, is going to be the last of our thought leaders, and he's going to be adding to the updates that we just heard from Jim Steiner, Brad Williams. And what Steve will be talking about are some of the architectural aspects and the best practices in the integration of Oracle Spatial and BI technology. He'll outline some steps that developers need to follow to spatially enable business apps using Oracle Fusion Middleware Map Viewer. And Steve has a tremendous background in this area. I've also worked with him outside of webinars, but he leads ThinkHuddle, and that's an Oracle Gold partner, and it's a provider of location intelligence services to primarily Fortune 500 clients and federal agencies. And what he does is specialize in solutions that leverage the spatial processing power of the Oracle database so he can help improve business processes and increase executive awareness of what is happening where in their business. Very passionate about that. Covers a broad range of industries, including utilities, biotech, financial, real estate, logistics, so on and so forth. Steve, absolutely delighted to have you back on the virtual podium, so I'll now turn it over to you.
Thanks, Mike, and thanks everyone for taking the time to join us today. Well, Jim gave you a great overview of the current state of the industry, and he showed how Oracle Spatial and MapViewer are helping people use location intelligence today. And Brad walked you through some of the business drivers that are leading to the development of apps like this, really comprehensive enterprise spanning applications. And I'm going to show you three things. We're going to start off by talking about why location is so important to utilities analytics. And I'm going to walk through a few different approaches people use to integrate location and business data. And finally, we're going to talk about the approach that we use to build Oracle Utilities Advanced Spatial Outage Analytics. So let's start off with talking about why location is so important to utilities. And it's kind of obvious why. It's important because they have so much more of it than other companies. You have crew locations for crews that are working on outages. You have assets and assets that are impacted by outages. Even the outages are locations in themselves. They might be represented by areas. And you have individual customers that are being impacted by outages. All of these things have locations. And utilities have more and more data coming at them every day. Smart grid sounds great, but what it really means from an IT point of view is more smart meters, more line monitors, distributed generation. All these things are leading to more and more devices, which is just more data. And now we have real-time crew locations coming from systems like MWM. These are all internal data sources you have control over, and they're still hard to manage. But you also have important location data that comes in from outside your network, weather radar imagery, lightning strike information, webcam feeds like in this screenshot here that give you a sense of ground condition. And while this data is important to other types of companies, most of them use it pretty passively. They don't use it to drive real-time decision making. So the important point I want to make about external data is that it's important to your daily decisions, but it's not directly tied to your systems. So that radar image or that lightning strike data doesn't tell you which transformer has been impacted. The only relationship between that lightning strike and your transformer is the proximity or the location. So that location, you can join those things together. Now on the next slide, we'll continue that train of thought. And I want to point out that location also matters when you have to answer questions that run across business areas. Sometimes the only way to join those systems together is on a common attribute, and it might not be a key. It might be a location. So location matters when you're answering questions about the now, like this first question here. That's which crew can best respond to an outage, and how long is it going to take them to restore service. And to answer that question, you need data from your outage system and your crew management system, which are probably independent. And it's also important when answering questions about the future, like what's the impact of outages on customer satisfaction? Or can I improve network reliability, get my SAIDI index up by replacing an underperforming asset? These answers require historical outage and potentially weather data. So you have current location data and potentially historical location data. If you have to answer questions like these without taking location into account, you're missing information that's vital to making the best decision. So let's say location matters. If it's important, then our solutions need to be able to handle a lot of location data and scale with it. They need to be able to pull in external data from weather feeds, lightning strike data, whatever that source is. And they need to be able to merge together business and location data from multiple sources. And this is a screenshot of what Brad was talking about earlier. It's Oracle Utilities Advanced Spatial Outage Analytics, and it can do all these things. Before we talk about how it works and what it is, I'm going to talk about how we built it and why we chose to build it that way. So there are lots of ways to integrate location into analytics for utilities, and we're going to run through three common approaches: a GIS approach, kind of a mashup approach, and then our approach, the business intelligence approach. Some are older, some are newer. I think the arrow summarizes my opinion. And let's walk through some of the advantages and disadvantages of each. So this is the kind of traditional approach to analytics. And the approach is don't integrate your location data into your business systems. Integrate your business systems into your GIS. This is very common in lots of industries. So your outage analytics becomes your GIS system. And there's one big advantage of these solutions, and that's that you get really fast and interactive mapping tools and deep analytics. Some of the drawbacks are that if you have lots of users, it can slow down the system. You might need to train users to use it because they're not simple interfaces. It's not good at displaying business data. You know, it's really for looking at maps. And because it's connecting straight to the GIS, GISs aren't really built to store historical data. They're best for looking at current state. So it may be for real-time outage management, not necessarily so good for looking at historical outage. So now let's look at the mashup approach quickly. So here I'm talking about homegrown mashups. And by homegrown, I mean this is where you aren't using a framework where you're mashing up business and location data together with code. These systems are usually database-driven, almost to a fault. You know, you've got lots of databases you're connecting directly to, and you're relying on external services for mapping, some service like Google or Bing that you're pushing your data up to. The advantage of these solutions is that they're easy to use, and they have, you know, in general, pretty fast interfaces. They scale well because you've offloaded the database work to the source systems and the map rendering work to Google or Bing. The outside data integration is pretty easy because that's what these are designed to do, and obviously you can build these solutions really quickly. So there's not really a strong architecture behind it. Some of the disadvantages are that you're using an external mapping solution, so you're not going to get the flexibility or spatial processing power of a GIS. And they're good at showing recent data, but you are getting it straight from the source systems, so you're not going to get much history. You don't have a centralized repository. And last, we're going to look at a BI-based integration. So BI environments are the latest place to see location and business data coming together. It's kind of been happening for a few years now, but it's finally solid and really usable. And it combines some of the best features of a GIS with the best features of a mashup. It's a little similar to the other approaches in some ways too. First, it uses a database just like a mashup, but it uses one database typically. And it's a faster database because it's a warehouse. And the BI server can cache results of queries to speed things along. And has something in common with the GIS, it's that it's using a dedicated map rendering engine that you have complete control over. So it's fast and rich. And it uses a very different approach to integrate business and location data. Typically in a GIS environment or a mashup environment, you're writing code to tie these systems together. And modern BI servers like OBIEE, this is done with product features, not code. So you kind of get the best of both worlds. You get features, scalability, performance, and flexibility of these solutions put together. The only problem with this approach is changes are easy after you build it. You have to have a warehouse with all your data in it to do this, so it takes some time to build. What if we combined all the features of these solutions into one system? What would that look like in a perfect world? So we'd want something that had the ease of use of a BI platform, had the map display performance of a GIS, the speed of a data warehouse, and the flexibility of a mashup. And I want it to show me current and historical data. This is what people want, but a framework or an approach alone can't deliver this, especially a low-risk implementation. So what Oracle did was wrap this up into a product. This is Advanced Spatial Outage Analytics. So Advanced Spatial Outage Analytics is an end-to-end solution based on the BI approach. And there are 3 Oracle products involved in this, and they're highlighted here. There's an Oracle database where business data and location data are stored. There's an Oracle Business Intelligence server that's used to pull data from the warehouse and build a rich, interactive user interface. And we use Oracle Map Viewer for map rendering. The nice thing about this product is you don't have to build the warehouse. It's already done. Oracle built the warehouse schema and all the ETL on top of the edge applications and all the BI dashboards you need to manage outages, crews, look at customers, and view reliability. And you can even play back outages over time, so outage history is available. I want to talk about 3 points on this solution. I want to review the Oracle products that are used in a little more detail. I want to talk about how we integrated location into the system and how the data comes in through the edge apps. So first we'll review the products. So at the core is an Oracle database, and its primary job is to store and retrieve location data. This is speaking from a mapping point of view. It does a lot more for the edge apps. We store things like assets that are points, service areas, which might be polygons, network models, geocoded customer addresses, anything with a location. And in addition to storage, it has to be able to run spatial queries across really large volumes of data fast and scale up easily. So this is where the data goes, and we need to get it out. That's what the Business Intelligence Server does. So OBIEE, or Oracle Business Intelligence Enterprise Edition, is just a BI platform. It has a lot of parts. We're going to talk about just a couple. Its primary job, from our point of view, is to pull data from the warehouse for dashboards. And it lets users build and modify existing dashboards all in a web interface. If you're looking at a dashboard, it provides drillable charts, data tables, and it has adapters to support federated data access. So you can pull data from any source, not just Oracle databases. So it's a little bit like a mashup in that sense. And the same solution is used by lots of Oracle applications like Primavera and Siebel CRM. So OBIEE handles the dashboard components, and we use MapViewer for the maps. I'm sure some of you are familiar with MapViewer. It's a web services map rendering engine, and it provides a lot of development toolkits, JavaScript, Java, PL SQL, and a generic HTML web services interface. It can query Oracle spatial databases and build maps using that data, in addition to other sources. It comes with map design tools and a really great developer API that lets you customize what the user sees on the map and control their interactions. So you can control which themes or layers show up on the map and what happens when a user clicks on an asset, like this pop-up window that's shown right here. So let's look at the MapViewer architecture. It's a 3-tier architecture, and MapViewer is in 2 of these layers. You see the Oracle Spatial Database down at the bottom, and MapViewer J2EE engine runs in the middle tier, and we have a JavaScript API that runs out on the client. We're not going to talk about the other APIs. The JavaScript API is the most commonly used, and it's the only one used in this application. And through that API, you can request scrollable maps, configure user interactions, and you can pretty much customize anything else you need to. It's really just an HTML page with JavaScript in it. So those are the 3 core components of the Oracle tech stack that this solution uses. It's an Oracle Spatial Database, Oracle Business Intelligence Server, and Oracle MapViewer. So now let's look at how the outage, location, and external data get from the utilities apps into the system. So it's ETL-based. You know, it's a data warehouse with ETL extractors running to pull the data in. And the great thing about this system is the extractors are already defined. So Oracle already has extractors, dozens of, if I recall the number, for all kinds of internal Oracle apps and third-party data sources like WeatherBug. And these extractors are updated as the source systems change. And the warehouse schema is updated as the sources change too. And it's smart ETL. It's not doing full updates from these systems. It's pulling near real-time updates in small incremental batches. And because it works that way, it doesn't impact your real-time systems. And it also doesn't impact your real-time system because the BI server is not connected to your source systems, like your network management system or your outage management system. It's only interacting with the warehouse. So this is how outage and location data from other utilities apps flows through the system. Where do the maps come from? So the map rendering is independent from the BI server. It's integrated into it, but it's handled completely by MapViewer. And MapViewer also handles the tie between business and location data. And it uses a feature that I could talk about all day called a non-spatial data provider. This is a core component of MapViewer. It's used by lots of customers and most of mine for lots of solutions, not just BI. And it joins data together from your spatial repository and whatever your other source is, OBIE in this case, using some attribute common to both data sets. So in our case, it's pulling XML from OBIE on, say, some report like outage counts by county. So in the OBIE report, we have a list of county names and the number of customers out in each county. Then it goes to Oracle Spatial and pulls matching geometries from the database by joining it on that county name that's also stored in that database. And finally, it merges those two data sets together, and from the client interface, you see a unified view. So a developer just sees county name and outage counts and the geometry all in one shot. OBIE 11G still uses this approach, but it's a much slicker configuration. So instead of configuring all this by hand, well, by hand I mean 3 or 4 lines of code, you get a wizard to do it in. So you can define the relationships between your OBIE data, your dashboards, and the tables over in Oracle Spatial. So you could say county in my BI server is the counties table in Oracle Spatial. And once that's been done, you can add a map to a dashboard the same way you would add a chart or a data table or any other component. And next slide. And MapViewer also provides native support for ISO and OGC web services like WMS, WFS, CSW. And in this application, we use WMS to pull Navtec street network data in on the fly. And what you're seeing there is a screenshot of Oracle eLocation. This is a hosted service that runs on top of Navtec data that's available to every Oracle customer. There are also native hooks to pull in Google or Bing Maps as base maps. So if you have your own WMS service, your own GIS data, or external data like WeatherBug, it's really easy to bring it in through MapViewer. So let's summarize advanced spatial outage analytics. I think we missed one there. So we can hop to this. So location is critical to decisions. That's good. Thanks, Mike.
You got it.
Location is critical to decisions utilities making today, and the importance of it's increasing constantly as new smart devices come online. And to handle all this location, you need a solid architecture. And OBI and MapViewer provides that. It scales well, provides rich and interactive maps and standard chart and table analytics. And you can enhance what's already there to build your own customized analytics. So you don't have to stick with what's coming out of the box. And finally, this solution that we've been showing you, Oracle Utilities Advanced Spatial Outage Analytics, is ready today. It's a low-risk implementation because it's just an installation. And you can get access to a broad range of utilities edge app data today. And obviously, note, location's completely integrated in the solution. Mike's going to show you where to go to learn more. Thanks, Mike.
Hey, thank you, Steve, and stick around. We've got some questions that are coming in, and we just have give a little bit information on where you can get additional information on what we've heard today. And we will provide this in the update email to you, but if you want to quickly write it down, it's here for you. And now we want to go to our final poll and ask you to vote on which of today's webinar or which aspects from today's webinar would be of most interest to you. And go ahead and choose all that apply. Would it be sharing spatial and operations data with decision makers, Oracle Utilities apps for outage analysis, network management, or integrated spatial and business intelligence out of the box, or integrating maps, spatial analysis into other maps? Go ahead. I'll keep the poll open for just a few moments. And while I'm doing that, if I could invite Jim Steiner and Bradley and Steve back to the virtual podium, I'll get ready with some questions. And I'm going to now go ahead and keep the poll open for about another 5 seconds. I'll close it, and then I want to get to some of the questions that we have here that are coming in. All right. Okay. Thank you very much. Let me close it. Let me share that. And 48% say sharing spatial and operation data with decision makers is what they would find of most interest, followed by 30% Oracle Utilities apps, 48% integrated spatial and be out of the box, and 78% integrating maps and spatial analysis. Thank you so much for that input. All righty. Gentlemen, let's start with the questions. Jim, this first question is for you from Eric. And Eric would like to know, how do you get GIS data in and out of Oracle Spatial, especially Esri file formats such as shape, file geodatabase, SDE, etc. And the second part is would also like to know how to serve Oracle Spatial data via ArcGIS Server Map Services. If you need me to repeat it, just let me know.
No, I think I got that. Let's start with the first. There are a variety of things. First of all, the Oracle product itself, Map Viewer with the Map Builder capability, has the ability to import shapefiles. It's actually wizard-driven, and you can just take any kind of shapefile and bring it into the environment, either into Map Viewer itself, or we have a utility that will take the shapefile and convert it into an SDO geometry. So if you're just using it as an overlay, we could just pull it in as an overlay map as a shape. Or if you want to actually bring it into the Oracle Spatial database, we have a Java shapefile utility that is both part of Fusion Middleware Map Viewer, or it can be used standalone. In addition, there are a variety of tools that support the loading of the ESRI data formats into SDO geometry. Esri itself, ArcGIS itself, has that capability. Also, Safe Software's FME has that capability. There's open source technologies, GDAL OGR. So there's a variety of technology. There's, I'm going to get in trouble with my business partners because pretty much every major geospatial ETL technology supports this. So I know I've forgotten. I think CISS in Germany or in Europe is one of the very common ones. But I may have forgotten others, and I apologize for that. But it is very, very straightforward to do. Now, the other element, actually now, Mike, I am going to ask you to remind me the second half of the question.
My pleasure. The second part is Eric would like to know how to serve Oracle Spatial data via ArcGIS Server Map Services.
Oh, that's the SDO geometry format, which is how Oracle Spatial data is stored, is a native data type to ArcGIS. So that's actually a simple configuration in ArcGIS, and that is also fully supported. And then again, another mechanism, I guess, would also be to use standard ISO OGC web services, web feature server, web map service. But it's a configuration in the ArcGIS system to support to use SDO geometry format.
Thanks, Jim. Brad, here's a question from Pete. Could the Oracle Utilities Advanced Spatial Outage Analytics work with the utilities customer existing outage management system?
Yes. Yeah. It's out of the box configured for Oracle Utilities Network Management System, but with some technical support on either from the utility or from an integration partner. It can be configured to bring in existing other third-party outage management systems as well. So yes.
Thanks, Brad. Got time for one more, then I want to give some important final comments on housekeeping. This one is, does Oracle's BI spatial integration require the use of Oracle's Map Viewer as the map rendering engine, or can other vendor map rendering engines be substituted? Who'd like to take that one?
Yeah, I can take that.
Okay.
So there's sort of two answers to that. Oracle BI can and has been able to be integrated with a variety of GIS tools, and if the question is map rendering, like map services, like Bing or Google or any of the others out there. Okay, start with, if you want to bring in Bing, Google, any of the others out there, that is fully supported will be fully supported very shortly to bring in those kind of background maps. In fact, I think it is fully supported today. If you want to bring in a different GIS, that can be done through a more custom integration, and there are many implementations of that today. But the actual very simple configure maps and do map analysis does rely on the the map viewer and spatial capabilities. But as I said, if you are simply looking at bringing in different background maps, that's fully supported today.
Well, Jim, thank you. And folks, looks like we're at the end of the webinar. As always, we want to keep to our commitment of being done within the hour. We'd like to thank you for joining us and trust that you found today's webinar to be of value. And of course, our sponsor, Oracle, and great presenters from Think Huddle with Steve Pierce and Brad and Jim Steiner. You're also going to receive a short survey in just a moment. We'd really appreciate you filling it out, as we'd love to get your feedback on how today's webinar met your expectations. Again, special thanks to my colleague Nora Parker for all of her behind-the-scenes work, but for her special on-air duties today for welcoming you as the official host from Directions Media. Again, you'll get a copy with a link in an email this week or the beginning of next week, so you can download this webinar to view it on demand, as well as some other information. And most importantly, thanks so much for joining us. We hope to see you on our next webinar in our webinar series. Have a great rest of the week, and be sure to tell a friend about Directions Media. This is Mike Agron as your moderator, saying bye for now.